All right, today looking at slopes of perpendicular lines. So the warm-up, just writing reciprocals. Remember, a reciprocal is just flipping the fraction over, essentially. So the reciprocal of 3 becomes 1 over 3. Reciprocal of negative 10 becomes negative 1 over 10. The reciprocal of 1/5, 5 over 1. The reciprocal of negative 5/4 is negative 4/5. The reciprocal of negative c, which is over 1, becomes negative 1 over c. And then the reciprocal of a over b becomes b over a. So reciprocals are going to be very important as we start looking at perpendicular lines. All right, on to the next page. It says, suppose the line segment is rotated through an angle with the origin as the center of rotation. We're going to complete the table based off the coordinates. All right, so a 90-degree counterclockwise rule. That rule changes our coordinates to negative y, x. So filling that in, 0, 0 is not going to change, but 8, 5 will become negative 5, 8. So that point is up here. Okay, and then for the next one, I'll do in red. Again, 0, 0 is not going to change. 180-degree rotation is negative x, negative y. So that point is going to become negative 8, negative 5. So negative 8, negative 5 would be right here, with the other point being the origin. And then for the third one, 270 degrees counterclockwise is our rule y, negative x. So again, 0, 0 doesn't change. And our point is going to become 5, negative 8. So 5, negative 8 would be right here. And it would create this blue line with the origin as the other one. Okay, so what do we notice about these figures, about this rotated line? Each time those endpoints are rotated 90 degrees counterclockwise, the coordinates are changing from whatever they currently are at xy to negative yx. And with one endpoint on the origin, that point is not changing. So all the point lines come together at the origin. And for 3, we're going to look at the slopes of these lines. Well, if we count the slope of each one from the origin out to the end point, we're going to find that for AB, our slope is 5 over 8. For the new AB, for letter B here, negative 8 over 5. For C, that slope is also 5 over 8 because it matches where line A is. And then line D, negative 8 over 5. Again, because it's just an extenuation of the line that was created by letter B. Okay, some patterns we see in the slopes. Okay, the lines that are intersecting each other, if you will, if I were to draw a right angle here, their slopes are opposite signs, reciprocals. Okay, and that defines the slope of a perpendicular line. Okay, so if we continue on to the next page, it says, recall that perpendicular lines or line segments form a right angle at the point of intersection. Consider the 3 graphs shown. And it wants us to show, each shows a line in its rotation 90 degrees about a point, which is the point of intersection. All right, so if we're looking at these 3 graphs, one says, are the lines in each graph perpendicular? Explain. And the answer there, yes. If we find the slope of each one of those, we're going to find that the slopes all are opposite reciprocals of each other. If we were to pick 2 points here, say here and here, it's going right 3, down 3. So that has a slope of negative 1. Negative 3 over negative 3. If we were to count our slope for this other line, we're going up 3, right 3. So 3 divided by 3 again is 1. Now with 1, you got to remember the reciprocal of 1 is still 1. So opposite reciprocals would just be 1 and negative 1. If we wanted to test that on one of these other ones, we can change colors here. This slope is down 3, right 1, so negative 3. The slope of the line that it's intersecting, up 1, right 3, 1 over 3. So 1/3 is an opposite reciprocal of negative 3 over 1. Okay, and we would find that for the last one too. You'd find your slopes here on the third diagram are negative 2/3 and positive 3/2. Again, opposite reciprocals. If I flip the fraction and then change my sign, we have opposite reciprocal slopes, so making them perpendicular. So now going back down below, we could say yes, all the slopes of, I'm going to continue it down here, intersecting lines are opposite reciprocals. Okay, we're not going to write the equation for each line. We're going to focus on the slope because that's our key determining factor when we're looking at slopes of perpendicular lines. All right, so on the next page, a few key words here. Theorem. The theorem we're looking at is if two lines are perpendicular, their slopes are negative reciprocals. I often say opposite reciprocals, just to remind you that we're just changing the sign. If it was negative, it now becomes positive. Okay, so this graph simply proves that. All it's showing is that if we take these two slopes and flip the slopes and change the signs, we end up with opposite reciprocals. We're not going to spend a lot of time on this diagram. That's all we're talking about is just taking our slopes, flipping them over, changing the sign. Okay, so for instance, this slope would be A over B. If we find this slope, it'd be the opposite of that. We'd be flipping it over and end up with negative B over A. Again. All right, so we're going to skip down. After 3, we're going to go to 4 because 3 was still following up on that diagram. So going to 4 on that next page, looking at this new diagram, it says line J and K are perpendicular to each other. Given each slope of line J, determine the slope of line K. So we're just practicing finding opposite reciprocals. So for letter A here, if the slope was 3/2, the perpendicular slope would be negative 3/2. So slope was 2/3, I should say. The perpendicular slope was negative 3/2. For B, if our slope is negative 4/5, the perpendicular slope would be positive 5/4. And for C, if our slope was negative 3, if you have to remind yourself that it's over 1, it's not a bad idea. Change colors. The perpendicular slope to negative 3/1 would be positive 1/3. And I left my M off on that middle one, so let me fix that. So perpendicular slope, there we go. So take it, flip it over, change your sign, and we end up with an opposite reciprocal slope. All right, moving down to activity 7.2, looking at horizontal and vertical lines. A horizontal and vertical line are perpendicular to each other. So one says use a straight edge to extend GK to create line P. So in other words, we're going to extend this and create line P. We're going to extend GH to create line Q. So Q. And we're going to extend FJ to create R. Oh, I meant to do that in yellow. FJ to create R. And we're going to extend KL to make line S. See if I can draw that a little straighter. S. All right, so consider the 3 horizontal lines we drew. Those are S, R, and Q. For any horizontal line, if X increases by 1 unit, how many units does the Y change? Well, by definition, if it's horizontal, the Y changes 0 units, no matter what we change the X by. So describe the slope of any horizontal line. The slope of any horizontal line is 0. Because rise over run, our rise is always 0 over some amount of run when we're talking about a horizontal line. Okay, 4 says consider the vertical line we drew in question 1. Suppose Y increases by 1 unit. How many units does X change? Very similar. X changes by 0 units. on a vertical line. And describe our slope of a vertical line. A vertical line has a slope that is undefined. Reasoning why again? If we think of slope, rise over run, our run in the x direction is always 0, and we cannot divide by 0. So that makes it undefined. So we cannot divide by 0. So that's why a vertical line has an undefined slope. All right, so determine whether each of the given statements is always, sometimes, or never true. Okay, so for 6a, all vertical lines are parallel. So all vertical lines, yes, those are always parallel. If they're vertical by definition, they all have a undefined slope and they're all parallel to each other. All horizontal lines are parallel. Again, yes, this is always true. Okay, 7, describe the relationship between any vertical line and any horizontal line. They are perpendicular by definition. They're always perpendicular to each other. That'll never change. Okay, so for 8, write an equation of a horizontal line and an equation for a vertical line that passed through the point 2, -1. So the key here is 2 is our x value, -1 is our y value. A horizontal line goes through the y-axis, so the horizontal line there would be y equals -1, and the vertical line would be x equals 2. So here would be our vertical, and here would be our horizontal. Okay, then for 9, write an equation for a line that is perpendicular to the line given by x equals 5 and passes through the point 1, 0. Well, x equals 5 is a vertical line through 5 on the x-axis. So what would be perpendicular to that would be a horizontal line. Well, the horizontal line that goes through this point would be the y value. Y equals the y value. So y equals 0 would be that equation. It would be the line that's cutting right through here on the x-axis. It would be perpendicular to our x equals 5 line and have a go through the point 1, 0. That point 1, 0 would be about right there. Okay, and then 10, write an equation for a line that's perpendicular again to the line y equals 2. So again, if I draw that, y equals 2 is now a horizontal line going through 2 on the y-axis. So we want to be perpendicular to that, so we're going to be a vertical line, and it's going to pass through the point 5, 6. Well, it's a vertical line. We're looking at the x value. 5, 6 would be somewhere up here, so we're going to go through 5 on our x-axis. So that equation of that vertical line would just be x equals that x value of the point, which is x equals 5. So vertical and horizontal lines are always perpendicular to each other. All right, moving on to 7.3. It says in the previous lesson we wrote equations of a line parallel to a given line that passes through any given point. Now we're going to write an equation of a perpendicular line. So perpendicular lines, again, opposite reciprocals. So if we want to be perpendicular to this equation, we need the slope of that equation, which is 2. So the perpendicular slope would be -1/2. And if we got a point we're given, we can write this in point slope form and using our perpendicular slope and get our equation. So we'd have y minus 2 from our point equals a slope of -1/2, and then x minus 6. Okay, for 2, same idea, want to be perpendicular. So if the original slope there is -3/4, our perpendicular slope would be positive 4/3. So again, use our point slope form. We'd have y plus 8 equals 4/3, and then x minus 3. Okay, for number 3, write in the equation a line that passes through the point 6, 2 and is perpendicular to a line that passes through these 2 points. So we got to use our slope formula to find our slope here. So we got y2 minus y1 over x2 minus x1. So that gives us negative 12 over, this becomes plus, so that'll give you 4. So that'll divide to be negative 3. So if the slope of the line between those 2 points is negative 3, the perpendicular slope would be positive 1/3. And then we got our point they want us to go through, 6, 2. So again, in point slope form, we'd have y minus 2 equals our new perpendicular slope of 1/3, and then x minus 6. All right, we got 2 more, very similar. Equation that passes through this point negative 2, 7 is perpendicular to the line through these 2 points. So using our slope formula again, y2 minus y1 over x2 minus x1, 0 minus negative 6. So that gives us 3 over 6, which reduces to be 1/2. So if our slope between those 2 points is 1/2, our perpendicular slope is negative 2 over 1, or just negative 2. So now if we want to go through that point negative 2, 7, again in point slope form, we'd have y minus 7 equals our perpendicular slope, which is negative 2, and then x plus 2. Okay, and then number 5. We'll change colors here for this one. A pair of perpendicular lines intersect at the point 5, 9. Okay, so this is a little bit different. Let me draw a little diagram. They intersect at 5, 9. So at this point here. And we want to know the equation of the line that is perpendicular to the line that also passes through negative 4, 4. All right, so if they intersect and are perpendicular, we need the slope of this line between these two first. So y2 minus y1. Oh, that's not right. Let's try that again. y2 is 4 minus y1 is 9 over x2 minus x1. So that gives us negative 5 over negative 9. So that'll turn into 5 over 9. Okay, well, that is the slope between the 2 points of that line. So we could write an equation for that line, and I'm going to do this a little different. I'm going to write, since they both go through the point 5, 9, I'm going to use that point for both lines. Now, one slope is going to be 5, 9. The perpendicular slope is going to be negative 9 over 5. Okay, but for both of them, I'm going to use that point 5, 9. So one equation would be y minus 9 equals 5 over 9, and then x minus 5. And then the other equation, same point, y minus 9, but now the opposite reciprocal slope, negative 9 over 5, and x minus 5. So those would be the 2 lines that are going through this point 5, 9 that are parallel to each other. They're going to look something like